Okay, we are now in the final topic before the departmental quiz on December 7, although that's still a tentative date. And after this, next week, we will have review. We will be doing exercises, and I will help prepare you for quiz 1. So let's have the last topic, which is systems of nonlinear equations. So um, in the system, at least one of the given equations is nonlinear. One can be linear, but there must be at least one nonlinear equation can have uh, both equations nonlinear, so quadratic. Start with the first example. So let's solve that system given by x squared plus 9y squared plus x equals 2, x squared plus y squared equals 1. Now, the technique that we will be using to solve nonlinear or systems of nonlinear equations is the technique of or method of elimination, where you multiply one equation by a constant, you add it to the other equation so that one of the variables gets eliminated. Thus, what remains is an equation in a single variable. So let's see that here. So observe the system. We have x squared, y squared, and x for the first one, x squared and y squared for the second one. Now we can eliminate either x or y. And in this case, we would have to eliminate y. Because if we try to eliminate x, okay, by simply subtracting the two equations here, we would still have an equation that is in two variables. So we want only an equation in just one variable. So we will eliminate variable y here. And if you observe the coefficients of y squared, you know that you have to multiply the second equation by 9 and then subtract, or equivalently multiply the second equation by -9 and then add. So we multiply this equation by -9. This is what we will have: -9x squared minus 9y squared equals -9. And then we add the two equations, thus eliminating the variable y, and we simply have an equation in x alone. And this is quadratic, which we know how to solve either by using the quadratic formula or by factoring. And it turns out that this equation is factorable. So we will do that. But first, let's simplify the equation. We transpose everything on one side of the equation. So we transpose everything to the right-hand side and then switch sides. We get this one, which is equivalent to the previous equation. 8x squared minus x minus 7 equals 0. And we factor it out as x minus 1 times 8x plus 7 equals 0. You may want to review your uh, factoring techniques. All you have to do is think of factors of 8 and factors of -7. So for the x, you can have either 1 and 8 or 2 and 4. And there's only one combination that will work. So this will have to be done by trial and error. Similarly, for -7, well, 7 is a prime, so the only combination is 1 and 7. So it's either the 7 here and the 1 here. But okay, what we have here is the correct combination. So you can just check this one. If you multiply this out, you'll get 8x squared minus 8x minus 7. And when we have factored the quadratic expression, all we have to do is equate each factor to 0 to get the solution. So we get x equals 1 or x equals -7 over 8. But of course, we are not done yet. what we have just found are the values for x. So we need to find the corresponding values for y for each x value. So that means we will have two cases, and we can use actually either of the two here to solve for y, but we'll use the simpler one, the second equation. So x squared plus y squared equals 1. So let's take x equals 1 and solve for y. So we plug in x equals 1 here. So we solve for y, transpose y squared equals 0. So y equals 0, which gives us the ordered pair 1, 0, okay, as a solution. For case 2, x equals negative 7 over 8, same thing, plug into x. You get this one, solve for y, transpose, you may use your calculator, you'll get this one. And sorry, this should be positive. Okay, positive 15 over 64. Square root as unreal. A negative number has an imaginary square root. This is positive. So we should have plus minus square root of 15 over 8. So this gives us negative 7 over 8, positive square root of 15 over 8, and then negative 7 over 8, negative square root of 15 over 8. So 3 solutions in all. So we write the final answer as in set notation in as ordered pairs. So we have the following solutions: 1, 0, negative 7 over 8, negative square root of 15 over 8, negative 7 over 8, square root of 15 over 8. So let's go to one more example. Oh, by the way, you're not required to sketch the system. So anyway, if you look at the system, actually, you'll notice that one is an equation of a circle and another is an equation of an ellipse. And as we have seen, there are 3 solutions, meaning graphically, there are 3 points of intersection as verified by the figure. This is one of the solutions, 1, 0, and then this point is negative 7 over 8 squared to 15 over 8. And opposite that, below, negative 7 over 8, negative square root of 15 over 8. But don't you worry about that. Graphing will not be part of the first quiz. So next, solve the system x squared plus y squared plus 4x minus 4y equals negative 7. Y equals negative x squared minus 4x minus 1. And let's see how we can employ the technique of elimination to solve this one. Start. Actually, you cannot directly use elimination. You have to convert first one of the equations by completing the squares, which is this one. Okay, let's we have to complete the squares for both. So that won't be shown since I have given 4 examples on that, one for circles, then for the 3 other conic sections. But just verify that if you complete the squares for both, for the first one, you'll get this one, x plus 2 squared plus y minus 2 squared equals 1. And then the other x plus 2 squared plus y equals 3. And observe that upon doing so, we have a common term, which is x plus 2 squared, which if eliminated would result in an equation in just one variable, y. So let's do that. Let's subtract the 2 equations. You can just multiply one by negative and then add to the other. So we have this one. So notice this cancels out. So we will be left with y minus 2 squared minus y left hand side, and then 1 minus 3 negative 2, which is now quadratic in y, which you can simplify. You just expand this one, collect the y, and then transpose negative 2 to the other side, verify that upon doing so, you'll get y squared minus 5y plus 6 equals 0, which is again factorable expression. And the correct factorization is y minus 2 times y minus 3 equals 0. So getting two solutions for y equals 2 and or y equals 3. And similarly, as with the first example, we solve for the corresponding values for x. So we'll use the second equation again. Well, it's also okay to use the first equation, but the second equation looks to be the simpler one, so we'll just use it. So we have it there. This is the second equation. So one of the solutions found is y equals 2. We plug in y equals 2 here. So we get x plus 2 squared plus 2 equals 3. So we transpose this to the other side. We get x plus 2 squared equals 1. We get the square root of the equation and take both plus and minus roots. So we get x plus 2 equals plus and minus 1. So we get two values for x. We transpose 2 becomes negative 2. So we get 1 minus 2 and negative 1 minus 2, getting the solutions negative 2, negative 1 for y equals 2. So when you write your ordered pairs, it has to be the x coordinate first, then the y coordinate. So this gives us negative 2, 2, and also negative 1, 2 as solutions. So case 2, y equals 3 again, plug in here. So we have this, 3 cancels out. So we have 0. So getting x equals negative 2 as the only solution for x. For y equals 3, thus we have negative 2, 3. And so again, we have 3 solutions for the system. Okay, negative 3, 2, negative 1, 2, negative 2, 3. The graph is shown. Okay, one is circle, the other is a parabola, and they intersect in 3 points as shown in the figure. These are the solutions found: negative 3, 2, negative 2, 3, negative 1, 2. Okay, that's it for this session. So there are practice exercises given. I want you to try them out to help you also prepare for the quiz. No need to graph the system. Okay, that's it.